Okay, yesterday we have discussed about myself and what is data engineering, how it is evolved, what is data engineer's role in IT industry, skills required to become a data engineer, job opportunities, and today we will discuss about how it is implemented in different cloud platforms and what is big data basically, and what is in our curriculum that we are going to discuss today. And as you know that data is very important, and that data, the data engineer's role is to translate that data into information by collecting data from different sources and processing the data and cleansing the data, managing the data, monitoring the data. All these are the different roles of a data engineer, and that is a good, choice you made to learn this course. As you know, that is a very demanding job in the current market. Okay, and as I told you about, this data comes from variety of sources including social media, IoT devices, sensors, APIs, data streaming, and more. So every day data is feeding in different formats, so that data needs to be processed for analysis purpose for the data scientists and data analysts. So the major role of a data engineer is to get ready the data, and that data will be used by the end users, that is data scientists and analysts, data analysts. Okay, and this is the process of an intelligent data warehouse. These are different data sources in the form of textual data, video data, images data, and document data. Different formats of data coming from different data sources. Okay, and using these connectors, by using different tools, we can extract the data and cleanse the data, transform the data, and load the data into this data warehouse. So this data again is used by the end users, that is data scientists and data analysts. And the major role of a data engineer is to be the meaningful data should be available. It's a kind of a lab technician, as I told you yesterday. So lab technician, without lab technician, that scientist cannot apply his methods, and he cannot formulate that meaningful insights on the data. So that's why that is a very major crucial role of a data engineer. And in our course, we are going to discuss in-depth uh, concepts, as our course is data engineering on AWS cloud, and how this all these tasks can be done with the help of Amazon Web Service tools. Okay, and also in this course we will provide you that how to prepare for the interview and interview question and answers discussions, and also resume preparation. So all those things will be there in our course. Okay, and modern data engineering teams are turning to the cloud to overcome all the earlier challenges. Means data warehouse is not provided the complete solution. So that's why, because it is cost more cost is there, and then people are required, large set of infrastructure is required. So to overcome those challenges, this cloud came into picture. So cloud-based software architectures are even more scalable, reliable, and secure than traditional on-premise data architectures. Okay, because we just uh, you need to pay only that particular usage of the particular software or the storage or the the complete infrastructure. And because the cloud is designed for distributed computing, it's the perfect platform for a modern data engineering. To manage this new distributed data architecture, a new variety of data engineers was needed, one with the skills to design, build, and maintain increasingly complex data systems. See, that doesn't mean that complex data systems in the sense the task is not a difficult task. Okay, you are not going to write any programming. Just only you need to understand mainly the database concepts like SQL and some scripting language. If you know more, like say SQL is a very important language in this data engineering domain, this career. So 80% of the SQL, and then only 20% if you know any of the language, like Python. Python is a popular language for data engineers and data scientists and for various applications. Okay, and data engineers responsibilities are these: client feeds the data, and he needs to get the data, and he needs to collaboratively work with the data scientists and data analysts, okay, by using different tools, databases, cloud infrastructure. Okay, so only you need to know about the tools only, not that you are not going to write a complex programming or analytical programming skills. You don't need to require all those. Just you need to know how to use that tool. That is very important. And when you see this diagram here, data engineer is the base for all these layers. All the customers are facing the different types, different kinds of domain, like risk operations, customer care, tax resolution, insights and operations, finance, product managers, marketing, benefits renewals, sales. These are the customers or the different domains, and these are connected with this no data science, engineering, business intelligence, anyone who can write SQL, BizTech, and in turn these are no dependent on this data engineer. So this is the core. So that's why there is a very huge demand in the market, the upcoming market also. So just you need to understand the foundations of what is big data and what is the architecture of the big data and what are different tools used to process the data. So that we'll discuss today. Okay, and as I told you yesterday, booming growth rate of 30.7%, the global big data analytics market is projected to be worth of 346 billion dollars by 2030. So boosting the fortunes of data engineers, business analysts, and data analysts, and also data scientists. So you can refer this Glassdoor also, the latest figures, the salaries, and in different countries. So they are highly paid job. This is a highly paid job. So that's what we have discussed yesterday, and today we will discuss about big data. Today these are the agenda. What is big data? History of big data. 5 V's. Earlier there are only 3 V's, but for the last 2 years, another 2 V's also added. What are those? We will discuss today about them. And benefits of big data. How is big data used? So these are the today's session agenda. What is big data? Are you all connected? Able to understand these concepts? Narayana, Surya, who is this heart? Can you please name?
Yeah, this is Khader.
Khader. Okay, thank you. Can you please introduce yourself?
Yes, my name is Khader. I'm working as chapter lead for one of the organization. I have little knowledge into big data, but not
Okay,
practically worked on it.
okay. So right now you are into which domain? Which technology you are working on?
Right now, I'm into management, non-technical chapter
Okay,
lead. Yeah, just want to um, be with technology. That's why I'm planning to learn this again.
good one. Good choice. Thank you, Khader. And can you please tell me about yourself, VVS Narayan Garu?
My name is Narayana. Good morning, sir. Good morning to all. Actually, I have worked for web development, UX designing, but I want to that interview calls is not there. That's why I want to join in data engineering. My friend is told another senior team leader.
Okay.
That's why
Okay.
I want to join this one course. Oh, actually, my MBA in 2013 pass out. If you have any placement is there, sir? Can you give the placement?
Okay.
Hello.
Yeah, yeah. Please go ahead.
That's why I want to join the data engineering, sir. My friend is told.
Good, good. Very good, Narayan. Thank you. Yeah, please mute yourself. And coming to what is big data? The term big data refers to large data sets, usually measured in terabytes or petabytes, hexabytes, that are analyzed to provide business insights. Okay. And as you know, that buzzwords like Hadoop and big data, there are two. I'll just open my whiteboard so that I can explain them. See, you might be hearing these two words, that is Hadoop. Okay. And the other term is big data. See, uh, these are basically two different terms, the buzzwords. So your friends might be asking about what Hadoop, the big data. These are the current technology, and then do you know about them like that? Basically, this is a solution. This is one of the solution. Okay, and this is a problem. Big data is a problem. To solve this big data problem, we use Hadoop technology tools. But that is one of the technology. Okay, so what is the problem? Data is, as every day data is growing, because everybody is feeding the data in the form of text and in the form of images, audio, video, documents. There are various formats, various types of data is incoming from different devices, different media platforms. Okay, But to provide the insights of that particular data, means to translate that raw data into a meaningful data, this Hadoop is a solution for that. Okay, because data is stored in various locations and in various formats, that we need to extract them and store them and process them. Storing and processing is the major role of a data engineer. Okay, then here the storage and the processing will differ. If it is the data is in a single system, it is very easy to process it, right? But this data is distributed in different systems and different locations. So this Hadoop is a solution to process the distributed data. Okay, and to apply the processing on the data, so that is the distributed processing. Okay, and these two, managing and processing, the file storage system and the processing are done by this Hadoop. So Hadoop is the first platform actually. That we will see how it is evaluated from the beginning. And this big data is defined by its variety, the different types of formats of data, velocity, the speed at which data becomes available, means you wanted to get the data in very less time, or if you wanted to apply some logics on the, or apply you wanted to get the reports on the historical data. So that depends on the speed of the data transfer, and the volume, the amount of data collected. These are the beginning days words, like 3 V's we can say: variety of data, velocity of data, and volume of data. And this big data can include structured data. Structured in the sense it is available in the form of a tables, like like structured means here that data may be available in the form of tables, like it contains header, and then it contains no columns. So as you know that that data is available in CSV file format or Excel file format. Okay, and then tables format in the form of a database. Like in database, all this data is stored in the form of a tables structure. So all these are the top header is called the columns, and these are the different rows, like here these are different rows. Okay, so here this is called a structured data. Like it contains a column name, like employee number, employee name, employee salary, his date of joining, his department. All these are available as a header. That those are called columns. The records, like his actual record, his number, that is a numeric type data, and his name, character type data, and his date of joining, date type data. Like that, all these are the records. So this is in the form of a table format. That is a structured format data. Okay, but unstructured data is also available. So what is unstructured data? Means there is no structure. So that may be in the form of a documents, in the form of a images, and the form of a video files or audio files. So that is called unstructured data. And semi-structured data, like it contains some form of JSON file, JSON format files, CSV format files. So those are belongs to this semi-structured data. Okay, and these are the main three types of data. This big data can include these three types, that is structured data, unstructured data, and semi-structured data. Although fully structured data is rare when dealing with big data. Okay, because earlier in olden days, in the olden days in the sense, in the previous 5 years, 10 years ago, we used to depend on OLTP systems. That is, yesterday we had discussed about the differences between OLTP, online transaction processing, like in banks or in shopping stores. All those are different kinds of online transaction processing data. So that data is stored in databases like MySQL, Oracle, and SQL Server and PostgreSQL, like that. Okay, but that is structured data, that is a transactional data. But nowadays, data is not available not only in the structured format, that is available in the form of a unstructured data. Like it is just, if you want to say, if you want to store, if you want to send your resume to another friend, you are just sending that, forwarding that resume in a WhatsApp. So that is a kind of a document. And if you want to share an image like your photos, so just you are transferring the data. So that is image data and audio data. So that is called a unstructured data. Okay, and semi-structured means, like to configure our systems or applications, we need to have JSON format data. Okay, so that is a semi-structured data. Now, history of big data. Here is a brief timeline of some of the notable moments that have led us to where we are today. That is, in 1881, one of the first instances of data overload was experienced during the 1980 census. The Hollerith tabulating machine is invented, and the work of processing census data is cut from 10 years of labor to under a year. So this is the first time that big data comes into picture. And in 1928, German Austrian engineer Fritz Flumber develops magnetic data storage on tape, which led the way for how digital data would be stored in the coming century. And like that, this is evolved. In 2005, Hadoop came into picture. That is an open source software framework, and that too, that is to store and manage, install in an on-premise location. Means on that particular, suppose, what is on-premise? If an office is located in one particular city, in that office only, they are going to install that particular software and hardware and all the infrastructure. That is called on-premise architecture or the technology. So that is the form of Hadoop. So that is a solution to solve these large data sets problems. Okay, and in 2007, the term big data is introduced to the masses in the wide article, The End of the Theory. The data deluge makes the scientific method obsolete. So from there, this term comes into picture, that is big data, in 2007. And in 2008, a team of computer science researchers published the paper Big Data Computing. Okay, and creating revolutionary breakthroughs in commerce, science, and society, describing how big data is fundamentally challenging the way companies and organizations do business. So that's where the solution came into in the picture to the industry. So that is a big data computing. And in 2010, Google CEO Eric Schmidt reveals that every two days, people are creating as much information as possible created from the beginning of civilization until 2003. Okay, Every 2 days, people are creating information as much as created from the year from 2003 until the civilization. Okay, so he has revealed that information to the public, to the world in 2010. Then in 2012, IBM study says 2.5 quintillion bytes of data are created daily, and that 90% of the world's data has been created in the last 2 years only. See, that was revealed, that was told on 2012. From there till today, see how much data is fed. Okay. And in 2014, more and more companies began moving their enterprise resource planning (ERPs) data, their systems to the cloud. Okay. The IoT devices became widely used with an estimated 3 billion connected devices or things in use, transmitting large amounts of data every day. So IoT devices like sensors and weather forecasting devices. So all that is all these are different data is feeded. So data is feeding every second, every minute. Like that, this in 2019, over 95% of business face some form of data, some form of need to manage unstructured data. And 2020, 59% of organizations state that they plan to move forward with the use of advanced and predictive analytics. Like by using the data, they are going to analyze it to make some organizational decisions how their business is performing in different locations by different customers. So that's where all the organizations are moving to know their insights of the data. And 2022 world projected to produce over 180 zettabytes of data by 2025. This is the estimated data. See how big this data is becoming now. This is the history of big data. Now, 5 V's, as I told you earlier, there are only 3 V's: volume, velocity, and variety. Now, there are 2 more V's are added, that is value and veracity. What is volume? Volume refers to the amount of data that is being collected. The data could be structured or unstructured. See, if you see this diagram here, volume, this is the scale of data. This refers to the sheer volume of data being generated every second. 6 billion people are having these cell phones, mobile phones. 40 zettabytes of data created by 2020, as just now we had discussed. And most companies in US have at least 100 terabytes of data stored. That is the volume, that indicates the volume of data. And then second one is velocity. This refers to the rate of which data is coming in. Means here streaming of data, analysis of streaming of data denotes the speed at which data is entering or feeding and changes are occurring between the diverse data sets. That is called velocity. Like here by 2016, it is projected there will be 18.9 billion network connections. Modern cars have close to 100 sensors. The work, the sorry, this New York Stock Exchange capture 1 TB of traded data. It's a stock market data. That is called this velocity, the speed at which the transferring the data through the network. Okay, and then the third one is variety of data. As just now we have discussed about this. This refers to the different kinds of data, data types, formats. Data is coming in the form for analysis purpose. For the last few years, these two additional V's are added. See, variety of data. If you see this here, variety here, 4 billion plus hours of video are watched on YouTube each month, and 30 billion pieces of content are shared on Facebook every month. 400 million tweets. Now it is renamed as, it is now acquired by X company, X. Tweets are sent per day by about 200 million monthly active users. This is the variety of data, video data, and then different textual data, image data, and this is the textual data. These are different kinds of data. Okay, and this data is every day, every now and then is more and more data is being digitized, means digitalized. So in the form of different kinds of data. So this is variety of data. Now value. This refers to the usefulness of the collected data. See, only having the data is not uh, use of that data. So how we are going to use that data, that tells about the value. See, value of data, having access to big data, all well and good, but that's only useful. Okay, so see, if we have some data without meaning of data, there is no use, right? So we need to have some value for the data. Okay, suppose if the Amazon wants to check how many products are sold today, so that is the value, how much revenue is generated from the sales, so that is the value. Okay, and the fifth one is veracity, refers to the quality of data that is coming in the form of different sources. Okay, veracity refers to the quality, value refers to the usefulness of collected data. See here, veracity, this refers to the discrepancies found in the data, uncertainty of data. Okay, so we need to have a meaningful data, and it should follow some guidelines also, that is called that data governance, and some principles we need to apply, security we need to apply. So this is the form of veracity. Okay, so these are the 5 V's of big data: volume, velocity, variety, value, and veracity. Okay, so volume refers to the amount of data that is being collected. Velocity refers to the rate at which the data is coming in, the time. Variety of data refers to the kinds of data, that is data formats. And then value refers to the usefulness of the collected data. Veracity refers to the quality of data that is coming in from different sources. So these are the 5 V's of big data. So this is one of the important point you need to remember. This will be asked in different different interviews. So what are the V's of different V's of big data? You have to explain these 5 V's. Okay, so that they will come to know that you have some knowledge on the big data concepts. Now, benefits of big data. These are the some notable areas where big data provides benefits. That is cost optimization, customer retention. Okay, customer retention in the sense, once you buy a product in Amazon e-commerce platform, that is on website, so again you need to come back and you need to purchase some other items. So the e-commerce platform, that is Amazon company, doesn't want to lose you. So by keeping some information visible to you, suppose you bought a mobile. After purchasing that mobile, after few days, again if you go to that website, that e-commerce site, so that if you open that, there is a waiting, like do you want to purchase the other items also belongs to your product, some suggestions. So these are the different kinds of that is available only when the data is available in the database. So those are called the, in the backend, they are going to apply some models by using data science algorithms. How and when they will apply only the data when the data is available. Then only they will apply the algorithms or models. Okay. So the data engineer's role is to keep the data available for these end users and decision making. So use of this benefits of this big data, main use of this one is making decision is very easy. If you have that insights of your business, you can easily decide in which location we need to improve that, and in which area or in which domain we need to improve. So these are the decisions the management will take only when this data is available. Okay. And the benefit of this big data is process automation. So once you design a pipeline or the stream of data, or if you perform an ETL job, you need not to do the same task again and again. Just you need to automate it by using some automation tools. Okay, Kafka and Airflow, these are the different Kinesis in our Amazon services. AWS, we have a Kinesis platform that we will discuss. What are the different tools used in big data platform by using AWS. Okay. See, once, as I told you yesterday also, once you know one platform or one technology, that is enough to switch or to move to the other domains, other cloud platforms. You have chosen a good choice because this AWS is started way before all the companies. In 2016 only they started their cloud platform. Basically at that time only, 2016 only, this big data comes into picture. That Hadoop came into picture. Okay, in the initial stage only, this AWS provided all the solution for this data science applications. So that's why if you are familiar with this AWS tools, you can easily perform any other platform's tasks. We are going to do the same task only by using the tools, but it may differ in different cloud platforms. Okay. Now, how is big data used? Personalized e-commerce shopping experiences. Okay. When you open any of the Flipkart or Amazon or any other e-commerce website, so you are going to use that website and you're going to purchase that some items. Okay. And then financial market modeling. And then suppose, see here, in the finance or in the insurance companies, in that industry, they use this big data, they use the big data to predict some fraud detections and risk assessments, credit rankings, brokerage services, and blockchain technology. So all these are the uses of this big data in the financial market. Okay. So these financial institutions are also using big data to enhance their cyber security efforts and personalize financial decisions for customers. And in the healthcare, so enhanced medical research from the data point of compilation. Okay, hospitals, researchers, and pharmaceutical companies adopt big data solutions to improve and advance healthcare. Not only in these domains, various domains, media, and also in the agriculture domain, predicting crop yields for farmers, traffic patterns, analyzing traffic patterns to lessen the city congestion. Okay, retail shopping habit recognition, and product placement optimization. These are all different uses of big data, and maximizing sports teams efficiency and value. Education habit recognition for individual students, that is in the educational domain. Okay, and when you come to this media and communication, this media and entertainment, if you have heard about this, Netflix, Hulu, any other streaming platforms, they provide the recommendations. Whenever you watch a web series or any other movie, they are going to display under that movie. There are some recommendations are displaying, right? So those recommendations are derived or displayed from this data science platform by using this data. So for that, you need to provide the solution. So to provide the solution, you are the backbone for that company. The data engineer's role is to make the data available to the end users. Okay. And these media companies analyze our reading, viewing, and listening habits to build individualized experiences. And Netflix also uses data on graphics, titles, and colors to make decisions about customer preferences. See how it is evolved in different ways of usages. And this big data in agriculture also, that is from engineering seeds to predict crop yields with amazing accuracy. Okay, and what are the different big data tools? Initially, as I told you, the widely used open source big data framework is Apache Hadoop. This is a software that allows for the distributed processing of large data across research, production, and operations. Okay, and this Hadoop is a solution for solving these big data problems. And the same architecture is adopted in different cloud platforms nowadays. When we are discussing about our AWS, you come to know that what is the tool in AWS to provide such big data solution. Okay, Redshift is the replacement for that Hadoop. But they have adapted the same concept, same architecture. So you need to know, everybody need to know about at least fundamentals of the Hadoop architecture. So you don't get bored, because this is the initial class demo, and you need to remember, you need to know about the background of this entire big data concepts. Okay, and Apache Spark is one of the tool, that is an open source analytics engine. See, to store the data, Hadoop is required in the form of file systems, right? HDFS file systems. But to process and to apply the processing methods on that data is a task of Apache Spark. So that is the processing of large scale data sets on single node machines or clusters. So we can use that Apache Spark in only single node or multiple nodes. We will discuss in the coming session what is a architecture of a Hadoop, and then architecture of this Spark. How this data is going to process in the form of a cluster network systems. Like when you see that Google engine, like in a Google search engine, when you type a word, it is going to get the results in a very fraction of seconds, like huge amounts of data. So how it is possible? The backend, they store that big data in the form of clustered network systems. Cluster is nothing but a group of computers. Okay. So to process that data, we need to use this big data solution, that is Apache Spark. Like that, there are many different tools are there. You need not to worry about it because we are working on AWS. So for every problem, there is a tool in AWS. Okay. Now we will see what is the actual data science platform architecture. This is very important. See here, this is the actual data science platform. This is a blueprint. Okay. You need not to worry about all the entire tools. Very simple. You just remember this diagram. Only there are three layers. That is connect layer, store layer, and visualize layer. And also this layers part is going to is not your job. It's not our data engineer's job. This is the job of data scientists and data analysts. And connect and store is our task. Connecting means through the APIs we are going to connect with different sources. Okay, it may be Excel data or CSV data or SQL data or application data. It may be any type of data stored in different sources. Our job as a data engineer is to just connect and get the data. Okay, so in our AWS, for connecting we use API gateway. Suppose if you are taking one example for insurance company to fraud detection data is available in CSV format. This is a data set. It's located in one location. So to extract the data, to get the data into our storage, so this connect is the layer. This is the connect is the layer by using different APIs through APIs or ODBC connections. If it is a SQL database, the data is available in SQL format. We can use ODBC or JDBC connections. Okay, this is the external source, and some people might be getting the data from enterprise data warehouses, from external data sources. Okay, this is the connect phase or connect layer in this data science platform. And then the second layer is, second stage is storage. Okay, that is in the form of big data, as we discussed about the big data, because it is a volume is very big, the size of the data is very big. That's why we call them as big data. And we may be storing the data in SQL DB warehouse, database or warehouse. So our SQL, to this SQL DBs in our AWS, we have a tool called RDS, DynamoDB, S3 buckets, Redshift. This is storage. So in the entire store, we have different layers again. Okay, we may be storing the data in the form of a RDS format, that is in the RDS in the sense relational data source. That means MySQL or Oracle database or any other Postgres, SQL, Teradata. These are all different databases. Those are called RDS in AWS. In AWS cloud, we call them as RDS. And if it is a no SQL database, like if it is containing some JSON data format, like a semi-structured data, we will be using DynamoDB in AWS for storing the data. If it is containing large set of data in the form of clustered, like Apache, Hadoop, or Spark kind of thing, you need to provide the big data storage in a data warehouse. We use Redshift in the storage layer. Okay, there are basically three stages. In that three stages, again, in this storage layer, we have three layers again here. That is processing, storing, and buffering. Okay, so here in our AWS, We use S3 buckets and DynamoDB, Redshift as a storage. Okay, and for processing, we use here, there may be different types of processing again here. That is stream processing, batch processing. Stream processing in the sense, what is stream processing? Like if it is a data is in the form of video format or audio format. Okay, we need to process the data using streaming tools. That is a continuous, like like in a near real time. We can call them as a near real time data. And batch processing. Batch processing is nothing but on a daily basis or on a monthly basis or on hourly basis, we are extracting the data from the sources and we are processing that data. Just it is nothing. It is not having any real time data. Just only a few past data, like past data only, historical data only. So that is processing the data is called batch processing. So here we use Lambda, and also for doing that ETL process, we use serverless computing in AWS, that is glue and step functions. Those are comes into this processing layer. Okay. Now, in the buffer area, see, once you extract the data and you need to process it, to process the data that needs to be stored temporarily in one location. That is in the form of a buffer. That is the form of caches and message queues. For that, in AWS, we have a tool called Kinesis. This Kinesis is used to store the data in a buffer. So these are the three layers in this storage stage. This is the connect stage, storage stage, and this is the visualization stage. Here, like this is the storage, the connect, and then visualize. So we will discuss about each and every topic, each and every tool in the form of a theory as well as practical live examples, live practice also. I will be providing this by using these tools. Okay, no need to worry about no, because here we don't do any programming here. Just using that tools, getting the data, processing the data, and make it available as a meaningful information to these end users for reporting purpose. And in this last phase, here in this visualization phase or in the stage, we use here web UIs or BI tools or mobile apps. Like in our AWS, we have visualization tools like called Grafana, and then you need not to learn this, but you just need to have some idea about that, because your job is to provide this data, and this is the job of the end users, that is the data scientists and data analysts. They are going to develop their, they are going to apply their models on our data and get the reports, and it is going to provide to the organization, the management. And here in scheduling, we use Airflow. That also we'll discuss in our course. That is for automation purpose, to automate this entire pipeline tasks, pipeline jobs. So we need to have one tool for scheduling. Okay. In the upcoming sessions, we will be discussing, and I will provide the entire live examples by using our AWS platform. Okay. So you have any doubts? Please ask if you have any doubts in today's session.
Sir, data scientist and data engineer both are same or any different?
No, data engineer is different and data scientist is different.
Okay.
Data engineer's job is to get the data and apply some, these tools. By using these tools, they need to have some, concepts like uh, ETL jobs, like extract, transform, and loading, cleaning that data. Suppose, the data, the source systems, the data may be not meaningful, right? So we need to process that data in a meaningful format. That is the job of a data engineer. And data scientists later use that meaningful data and apply his algorithms or the machine learning models or the data science algorithms on that data, on top of the data, and he will get the reports.
Okay, data engineer maybe like infra side, and data scientist is towards development side, sir.
Yeah, like, it is a bit like the same, like,
Okay, and what is the salary range, sir, for data engineer?
see, yesterday I told you about this, no, when you go and check this glass door, in India, minimum 10 lakhs per annum, okay? And in USA, here, this is according to Glassdoor, the total annual pay a data engineer earns around 1 lakh 11,000, almost 1 lakh $12,000, including his base salary, additional bonuses, sharing, and also they have some sharing, profit sharing also. Okay.
Okay, okay, thank you.
So here, as you asked, the primary task of a data engineer is to design and construct, maintain the data. Okay, and optimize the data pipelines. And the responsibility is nothing but here, that is ETL, extract, transform, and load, and then designing and maintaining the architectures. Okay, and these data engineers are collaboratively working with the data scientists. That you need to remember. Okay, but whereas data scientists' main focus is uh, that insights, applying some patterns, algorithms, and models, and they will use those BI tools like Power BI or the Tableau. Those are the tools they use. That is the major difference. Okay.
Okay, sir.
Anybody has any doubt?
I have a quick question. I know you mentioned that we will be using SQL like 80% of our, in the whole data engineering side. So is that something we should be practicing starting now, just to get ahead, or is it gonna be covered in the course, throughout the course, or is that something we should be
Yeah, we
practicing
have.
now?
Yeah. Uh, I will share you that. Okay, I think time is over. See, basically, uh, I will teach you. I did not mention in the course curriculum basically, but as a bonus, in this course, we are going to provide Python and SQL as an additional tools. Okay, I will
Okay.
tell you about. I'll teach you how to use SQL and what is SQL. What are the different types of SQL commands available, like data definition language, data manipulation language, data transaction language. Okay, and different types of joins and different types of classes, means commands, like where clause, group by clause. I will teach you all those things as an additional course bonus as a bonus. That's a free,
Okay.
and you will practicing them, on any one of the database in MySQL, mostly. If you practice in any one database, that is enough.